This section is actually going to be mostly new. We're going to pull some of conceptually what we know about parabolas, and then we're going to stretch it a little bit to mean a little bit more, because we're going to do some non-function parabolas like y squared instead of x squared. What this paragraph talks about is you have this a cone. So if you were going to take a cone and then you were going to cut it with maybe a line or a plane or something, you can see you get these conic sections, all right? And so you take a cylinder, we know what cones and cylinders are, and you cut it and you get these slices that appear. And so this is what it's talking about. If you were to take maybe these lines here and spin them, you could see you would get two cones, right? And it generates this picture here. And then you can cut those different ways. So if you look at right below that picture, they start telling you about the different ways that can happen if you were to put a plane cutting through something like that. If I were to put a plane down here, you can see that what is created here is a parabola. If I were to put something like this, an ellipse, right? An ellipse is just like a stretched out circle, right? Ellipse. If I were to do it parallel to those bases, I would actually get a circle. And then you get a hyperbolic function, one that comes up and back down, almost like two parabolas on top of each other here. And so these are some of the ways that can happen. And then you have these specialty ones here. If you went right in the middle of those two cones, you would be at a point, okay? If I were to go down exactly the slant here, I would actually have a line. And then if I were to go straight down the middle of the two cones, you can see I would have those two intersecting lines. And so as you start taking these sections, we're going to deal with these right here in this chapter. And we're going to start with the parabola. So we're going to start with something a little more familiar. And then we're going to move to the ellipse and the circle, circles are a little more familiar than ellipse. We haven't done a lot of those. But parabolas we've done a lot of, but now we're going to start looking at them from a different perspective. Okay, so we're going to shift we're going to take from what we already know about parabolas, and then we're going to add to it. Okay, so let's start with the definition of parabola. Definition of parabola. A parabola is a set of points in a plane that are equidistant from a fixed line. Directrix is a new word. Typically, when we have dealt with parabolas, the direction has always been in reference to the x-axis, either up or down from that, okay? And a fixed point, it's focus, so fixed point, not on the line. So basically, when you think of these, the directrix is going to be below the vertex or above it, depending on which way it's facing. And the focal point, or the focus, is going to tell you which way it's going. So like if this is my directrix underneath my vertex, my focus should tell me which direction this guy is going, which direction that center axis is headed, okay? This is gonna help us with word problems too. But this is how this directs it right here. A couple things about this. We have some distances that happen. So if you were to pick a point on this particular line here, we have a distance here and we have a distance here. You can see this creates a right triangle. And we're actually going to end up using this with some distance formulas that we've done in the past to help us figure out where it is, okay? And so just keep this, I'm going to pop this figure back up in a minute to do some other things with it. But these are new terms that we're not used to, because we're used to this always being the x-axis, right? And so from that point, we always knew it pointed either up or down based on the positive and negative. But then when you start doing y squared, which changes it to be parabolas that aren't actually functions because they're sideways, then which way does it go depends on those two things. And so we're going to throw in some formulas on how to calculate these. All right. So, right here it says, we now have a new formula for our parabola. Remember before we had a x minus h squared plus k, right? So instead of a, we have this 1 over 4p, 1 over 4p. They give the whole proof of this, but I think it would actually give you a headache if I did it. So that's okay. We're just you'll be fine not knowing the proof. But you can see it comes from the distance formula. So what they've done is they've taken the distance formula here, the distance formula here, and those are going to be equal to each other. This actually creates an isosceles triangle if I were to connect here to here. All right? And so if my directrix, which is that little line we were talking about under the vertex, and my focal point or my focus, if I look at those two and I go from here to here and then from the directrix up to this point, it should be the same distance. So how they've come up with this is they use the distance formula to do it. All right? A couple things. This must mean, if this is the formula, this must mean you can assume that A then is equal to 1 over 4p. That's all you can assume if that is the formula for a parabola, right? Because in years past when we have done parabolas, this has been an A. But we're introducing this new point on the parabola, the P, that is going to help us solve some things. So A is going to equal 1 over 4p, and if you need to solve for P, you would just solve equations, and it comes out to be P equals 1 over 4a as well, right? If you were to solve this like a literal equation to solve for the other variable. So A equals 1 over 4p and P equals 1 over 4a. Those are things you're going to want to remember as we go forward, because there are going to be times when you want to know that P value, okay? And you've been given maybe A. All right, so let's look at standard forms of a parabola then. All right, so the first one is what we're familiar with, the regular up and down parabola. All right, the up and down parabola. The directrix is the line that is equidistant from. All right, so it is equidistant from this, meaning every point on this is going to be equal distance from that guy, okay? We're used to these. We're used to up and down, okay? So we still have this. This will still tell us if it goes up and down. That A value, or 1 over 4p, will still tell us the up and down. But we have some other things here. How do we solve for where this focus point is? We're going to use our H, just like we did when we did our vertex. And by the way, our vertex is still HK. We're going to use our H, and then the other value, or the Y value of my focus, is going to be K plus P. So we're going to use the K, and we're going to add the P. This is why we need to know that P value, okay? X equals H, that is still my axis, as it always has been. My directrix, so this line that's equidistant, is going to be K minus P. So we have K plus P in the focus, and we have K minus P with the directrix, okay? This is when it's Y equals an X squared. We can also have X equals a Y squared. So X equals a Y squared shifts how that parabola is drawn. You'll notice this one goes up and down, these go left and right. So these switch. While this was H, K plus P, this is H plus P, K. So it's a little bit different here. X is going to be H minus P. My Y is going to be, Y equals K is going to be my axis of this guy. Notice the formula too. We're used to it being HK. When it is X and Y's are switched, so are my K and my H's, okay? So this is HK like we've always done it. When it is X equals a Y squared, my H and K have switched places. So don't let that throw you when we start doing these problems. Example 1 says, graph Y equals -1/2 X plus 3 quantity squared plus 2, and its vertex, focus, and directrix, all right? Vertex is easy. This is a Y equals X squared. We've done this before. So the vertex is just going to be my HK. So my vertex here is -3, 2. Remember, the regular formula is a minus there. So the reason I did -3 is because it was already a minus in my original formula. So use the opposite there. Let's look at focus. So if I want to graph my focus, then I am going to use this formula down here. This formula down here. My h is easy. I already know what my h is. My h is -3. The other piece that we need then is p. When they give this to you, they have given you a, right? So we need to find p, and if you'll recall, as it told us up there, p is just going to be 1 over 4a. So I'm going to say 1 over 4 times -1/2. That actually ends up just being, by the way, -1/2. So my p is -1/2. It won't always end up to be the same as a, but in this case, it actually happens to be the same, all right? So my y value of my focus is k plus p. I'm going to take my k value, which is 2, and I'm going to add to it a -1/2. All right, so that is my y value of my focus. And of course, I need to simplify that. So it's going to be -3, and then 2 plus -1/2 is just 1.5. Okay. And they want me to graph that as well. So -3 and 1.5, which is going to be right here. -3 and 1.5. They also want me to find my directrix right here. So my directrix is going to be y equals k, which is 2, minus p. We already found p. So it's going to be y equals 2.5. So that's going to be a horizontal line at 2.5. That's this guy right here. All right. So I can still find my y-intercept if I want to know how wide this thing's going to be. It's not going to be your standard parabola width because of that 1/2 in front of it, right? So I can find either my x-intercepts by setting the whole thing equal to 0, or I can find my y-intercept and still graph it that way. If I plug in a 0, I would get 0 plus 3, that's 3, quantity squared is 9, -9 halves plus 4 halves, right? And so you'll get what, -5 halves. So you can still do that if you want to figure out where to continue this graph, right? And you can still draw your axis if you want to. It doesn't matter. But you're going to graph this thing just like you would any other parabola. It's going down, it's going down. And this part right here is my focus. I think they labeled it with an F right here. And this is my directrix, and they labeled it there. All right? This is going to help us when we get to our word problems. So I want you to try one. So in this case, they have given us our focus, and they have given us our directrix, okay? And so if we know this right here, we actually know which way it's going. This tells us which one we're going to use. If my directrix is an x equals something, then it's going to be set up like this problem. If my directrix is a y equals something, then it's going to be y equals for my problem. So this parabola is going to be a left-right parabola, not an up and down problem. I already know that by this right here. And then I'm just going to back plug those in to figure out what I need to do to get the actual problem in standard form. If I know this, I'm really trying to find P. So I know that H plus P should equal -1. Based on this, the fact that they gave me my focus. H plus P should equal -1. They've also given us the directrix here. We know the directrix is H minus P. So I have H minus P equals 3. 2H equals 2. So H equals 1. So then my P should equal
4. No, sorry.
-2. I have my P. I can go back and figure out what's going on. My A is really easy to figure out right now because I can just say, well, if I have P, then I know that A equals 1 over 4 times P. So my A is going to be -1/8. So in my standard formula here, X equals A. That's going to be -1/8. Y minus my K. I already have my K because they gave me my focus. This is my K here, so I already know my K squared, and then plus H, which I've already solved for, plus 1. That is my standard form of this equation. So when they ask for standard form, they want y or x equals a quantity, the other variable minus h or k, depending on what it is, squared, plus h or k, depending on which one it is. That's what they're looking for. It says graph this function and its focus. This is actually not a function, so. And its focus and directrix. Okay, so when you have something like this, you want to get it into either x equals or y equals. So you're going to look and say, well, which one is by itself? The x is by itself. And so we're going to get it to one side. So I'm going to move my x to one side. And I'm actually going to flip-flop the sides. So I have x equals 2y squared plus 4y minus 1. Okay. So when I have something like this, I need to get it in vertex form, pretty much, is what we call it, right? Our a quantity, x minus h squared plus k. So I want to get it in vertex form. This is not in vertex form. To get this in vertex form, I need to factor that 2 out. So I'm going to say, well, that's 2y squared plus 2y minus 1. I need to make that a perfect square so that I have some group squared. So this is where our beautiful, we love solving things this way, completing the square comes in, okay? How do I complete a square? Well, I take this center guy, I cut it in half, and I square it, right? So 2 divided by 2 is 1, 1 squared is 1. And I am going to just randomly throw a 1 in here. I have a problem. That changes my equation, doesn't it?
Yeah.
I can't just throw a 1 in there. So I'm going to also subtract it back out. Did that change my equation?
No.
No, it did not, okay? Here's the other problem. I need that negative 1 out of my parentheses. Go back to algebra 1. How do you get something out of a parentheses?
Wait.
How do I get something out of parentheses? I have 2 times x plus 2. How do I get rid of my parentheses? I distribute, do I not? Okay, so I'm going to distribute, but I'm only going to distribute to the guy that I need to come out of the parentheses, okay? So I'm going to distribute just to that negative 1, because that's the only thing I want to come out of the parentheses. So my 2 and my y squared plus 2y plus 1 will remain in the parentheses, but I'm going to multiply that negative 1 to get him out. 2 times negative 1 is negative 2, okay? How does this help me? Well, it helps me because now I have a perfect square trinomial, which is really what I was trying to do the entire time. All right? So I was trying to get this to be a perfect square. I have done it. And so I can now rewrite this piece of it to be y plus 1 quantity squared. And negative 2 minus 1 is negative 3. That is what I want it to look like. It must be in that form for me to find my focus and for me to find my directrix, okay? I have to do that. So, all right, I am going to go ahead and write out what my P is. My P is going to be 1 over 4 times my A. So my P is going to be 1/8, right? And then I'm just going to do this process to find my focus and my directrix. If I want to find all my pieces, my vertex is still HK, but this is a Y one. So my H is negative 3 and my K is negative 1. Okay, so if I'm graphing this, my vertex is negative 3, negative 1. My focus is going to be H plus P. My H is negative 3, so negative 3 plus 1/8. And then K, which is negative 1. So my focus is going to be negative 2 and 7/8-ish, negative 1. So it's going to be like right here, right on top of it. Right, there's my focus. All right. My directrix is going to be x equals h, my h being negative 3. And then minus p, my p was 1/8. So negative 3 and 1/8 is my directress. He's going to be right here. All right. And then I just need to graph it. This one's a little crazier to graph with your x-intercept, but you can. Plug in a 0 here. 0 plus 1 is 1 squared times 2 minus 3 is negative 1. So it's going to be a really sharp graph when I do this. So it's going to look something like this. That is my parabola. Find the equation of the tangent line. Okay, so if I have my focus and some point on the parabola, okay, then the distance from my focus to the point on the parabola is going to be the same distance to where that tangent line crosses my axis. So the distance from F to P is going to equal the distance from F to A. And if I want my tangent line or the equation, to find the equation of any line, if you have 2 points, you can find the equation. That's just is what it is. You find the slope, you've got it, okay? So, they want me to find the equation of the line tangent to this parabola that goes through this point. So to do that, I need to find this focus, and I need to find the distance from this focus to this point. I need to take that guy and find a point that lies on this that is the same distance away. Okay? So, they were nice and gave me a 0, 0. So they gave me something that's on the 0, 0 right here. So that's going to be a little bit easier. So the first thing I'm going to do is find my focus. My focus, as we've said before, is h k plus p for this guy. If I look at this, my h and k are both 0. This is 0, 0 for h and k. So my focus then is going to be 0, and then some 0 plus whatever p is, k plus p. So 0 being my k plus my p. So I really need to find my p. P is going to be easy because it's going to be 1 over 4 times this negative 1/2, which actually ends up being negative 1/2. So my focus then is going to happen at 0, negative 1/2. So I have that guy. I need to find the distance to this guy. How do I find distance between 2 points? There we go. So I'm going to say 0 minus a negative 2 quantity squared plus negative 1/2 minus 2 quantity squared. You actually get a fraction, 25 over 4. So 5/2, that's the distance. So what's nice about this guy is I already know the x value of my point up here, right? And if it were going this direction, I would already know the y value because it's going to be on that line. So my x value of this point where this crosses here is going to be the same x value as my focus. So point A is going to have a point right here of 0. We know that. And the y value of this is just going to be my focus y value plus the distance away that I said it was. It was 5/2 away. So I'm going to say, well, that's going to be negative 1/2 plus 5/2. All right, so that point right here is just going to be 0, 2. So now I know 0, 2 and negative 2, 2 are on that particular line that I'm trying to find the equation for. I need to do just basic slope equation information. How do I find my slope? Well, my slope is y2 minus y1 over x2 minus x1. y2, negative 2 over y1, or minus y1, so I have negative 4 over negative 2 minus 0, negative 2. My slope here is 2. How do I get my y-intercept? Well, they actually already gave it to me. This is my y-intercept. If I have the point 0, 2, I actually already know my y-intercept. So the equation of that tangent line is going to be 2x plus 2. You are finding the distance from your focus to the point they're talking about, taking that distance and finding either the x or y value, depending on which way this parabola is facing, to find the other point, and then you have 2 points on the line. And I should not have to show you how to do 2 points on the line at this point, because you should know how to do it.